Hey guys, my name is Varun and welcome you to another video of We Teach Math. From this video, I'm going to start at level 2 permutations. So let's get this started. First question is prove that if R less than or equal to S less than or equal to N, then permutation of N and S is divisible by the permutation of N and R. In simple words, we have to prove that permutation of N and R is a factor of permutation of N and S. We have to prove that n factorial divided by n minus r factorial when multiplied by a particular number gives n factorial divided by n minus r factorial. To do this, we expand this formula n factorial divided by n minus s factorial to such a point where we are able to find n factorial divided by n minus r factorial existing as a part of the product which gives n factorial divided by n minus s factorial. Let me explain detail. So first, as I said, we expand n factorial divided by n minus s factorial. Now a factorial is a product of numbers steadily decreasing by 1, right? N is any positive number, so the multiplication starts from a particular positive number n. So n can be any positive number. For example, let us take n is equal to 3. 3 factorial gives a product of steadily decreasing numbers starting from 3, that is 3 into 3 minus 1, that is 2. With this product is further multiplied by 2 minus 1, which is 1. So 3 factorial is equal to 3 into 2 into 1. Right? Similarly, the multiplication product process starts from n is multiplied by n minus 1, the whole product is multiplied by n minus 2, and so on. This multiplication process continued till we get a number that is n minus of s minus 1 into n minus s factorial. Over here n is always greater than n minus s, right? So when in n factorial, n minus s factorial must exist as part of the product. So n multiplied by n minus 1 multiplied by n minus 2. The multiplication process continues till n minus of s minus 1 into n minus s factorial. So you get n minus s factorial in both the numerator and denominator. So you cancel them both. So in the next step you get n into n minus 1 into n minus 2 and so on. And the last number of the multiplication process is n minus of s minus 1. As I said, s is equal to r plus k. So where k is any random number, right? If s is greater than or equal to r, you can take s is equal to r plus k. Since s is greater than r, we can take k as any random positive number. So let s is equal to r plus k. So over here we replace s with r plus k. So n multiplied by n minus 1 multiplied by n minus 2. The multiplication process continues till n minus of r plus k minus 1. So over here n minus of r plus k minus 1 is like n minus r minus k plus 1, right? Over here n minus r is greater than n minus r minus k plus 1. If a number less than n minus r exists as the end of the product, n minus r must exist at some part of the product, right? Because n minus r is greater than n minus r minus k plus 1. So that means n minus r must occur no matter what before n minus of r plus k minus 1. So we assume it, right? So in the next step, n into n minus 1 into n minus 2, there are some other numbers multiplied in between till you get n minus r minus 1 multiplied by n minus r multiplied by n minus of r plus 1. Multiplication process continues till n minus r plus k minus 1. So over here this is the same as p of n r, right? Just as you did for p of n and s, in n factorial divided by n minus r factorial. We start the multiplication process till and end it with at n minus r factorial and cancel both numerator denominator. So the multiplication process starts at n and ends at n minus of r minus 1. So this and this is what constitutes p of n and r. Thus we prove that p of n and r into n minus r into n minus of r plus 1. Multiplication process continues. And yeah, so from this expression it is clear that p of n and r is a factor of p of n and s. The next question is a bit tricky. You have to read the question again, right? In an examination hall, there are 4 rows of chairs, right? Each row has 8 chairs, one behind another. So the number of chairs in each row is 8. There are 2 classes sitting for examination with 16 students in each class. It is desired that in each row all students belong to the same class, right? Meaning and that no 2 adjacent rows are allotted to the same class. In each row all students belong to the same class and that no two adjacent rows, that means rows next to each other, right next to each other, are allotted to the same class. That means students of the same class cannot sit in 2 rows which are right next to each other. For example, row 1 should consist of students of class 1 and row 2 should consist of students of class 2, right? Class 1 cannot sit on both the rows, right? In how many ways can these 2 students, apologies, I meant classes, these 2 classes can be seated? These 2 classes. So each row has 8 chairs, one behind another. There are 2 classes sitting for the examination with 16 students in each class. That means a total of 32 students. It is desired that in each row all students belong to the same class and that no 2 adjacent rows are allotted to the same class. That means the classes should be arranged alternately. Class 1 should sit on row 1, class 2 should sit on row 2, class 1 should sit on row 3 and class 2 should sit on row 4. There are 4 rows, right? Okay. So here there are 2 ways of ensuring this, right? There are 2 ways of ensuring that the classes are sitting in alternate rows. If the arrangement starts with C1, this is case 1, right? The 4 rows are named R1, R2, R3, R4, right? Let's say the arrangement starts with C1, C2 is on R2, C1 is on R3 and C2 is on R4. Because each row can hold only 8 students, that means a class needs 2 rows. C1, if the arrangement starts with C1, then C1 takes R1 and R3. If the arrangement starts with C2, in the case of case 2, then the C1 takes R2 and R4 and C2 takes R1 and R3. So in case 1, number of students in class 1 is equal to 16. Okay. Number of students in each row is equal to 8 because there are a total of 8 chairs. Okay. Just to let you guys know, I'm sorry. The 2 classes are named C1 and C2. Alright. Okay. So number of students in C1 is equal to 16. Total number of students in each class is 16. And number of students in each row is equal to 8 because there are only 8 chairs in a single row. So over here we have 2 different ways of doing this job, case 1 and case 2. Over here we can't use multiplication principle because case 1 and case 2 are 2 separate ways. They're not 2 separate steps. So we have to add both of them, right? We have to find a number of ways of case 1, we have to find a number of ways of case 2 and add them both. So now we have to find the number of ways of doing case 1. So here number of students in class 1 is 16. Number of students in each row is equal to 8. So here step 1 in case 1 is arranging students of class 1. Alright. Number of ways students of C1 can be separated in rows of 8 is 16p8. Let read it again, guys. Number of ways students of C1 can be separated in rows of 8. What they mean to say is total number of students is equal to 16. 8 of them are taken at a time, right? In each row there are 8 students at a time. 8 are taken. So we have to find number of permutations for a total of 16 students when 8 of them have been taken at a time. That is 16p8. We have to find the permutations, right? This is step 1. Step 1 is separating the students into 8 different rows. Now step 2 is arranging them, arranging students of each row. We have to find number of ways or number of arrangements of the 8 students in 8 chairs. Alright, that is 8 factorial. That is because, let's see, the job is arranging assigning each student with a chair. Alright, we are talking about a particular row, that is 8. So the first student has 8 options, second student has 7 options, third student has 6 options, and so on. 8, 7, 8, 7, 6, 5, 4, 3, 2. Step 1 is ensuring the first person gets his chair. Step 2 is ensuring that the second person gets the chair. Step 3 is ensuring that the third person gets the chair, and so on. So number of ways of getting this job done. Number of ways of arranging the 8 students with 8 chairs is 8 factorial, because we have to find the product of the number of ways of each of its steps. Step 1 is ensuring the first student gets a chair. Step 2 is ensuring that the second person gets the chair. Step 3 is ensuring the third person gets the chair. That is 8 into 7 into 6 into 5 and so on. That is 8 factorial. So we found the number of ways of step 1 and step 2. So number of ways of arranging 16 students in rows of 8 in C1. That is the number of, as I said, multiplication principle, guys, states that the number of ways to do a job, an activity or an arrangement is the product of the number of ways of each of its steps. So we found the number of ways of step 1 and step 2. So we have to multiply them both. That is 16p8 into 8 factorial. That is 16 factorial divided by 8 factorial into 8 factorial. That is 16 factorial. Similarly, number of ways of arranging 16 students into rows of 8 in C2 is also 16 factorial. Similarly as in C1, C2 also goes to the same process. So over here, now in the job of arrangement in case 1, we have 2 steps. Step 1 is arranging class 1. Step 2 is arranging students of class 2. So the number of ways of getting this job done is the product of the number of ways of each of its steps. That is 16 factorial into 16 factorial. Similarly for case 2, we get the same answer, that is 16 factorial into 16 factorial. Therefore, number of ways of seating arrangements is equal to number of ways of arranging case 1 plus number of ways of arranging case 2, that is 2 into 16 factorial into 16 factorial. I'll give you a few minutes time to take photos of these. Alright, pause the video and take your photos, guys. Okay, I'm scrolling down. Now for the next and last question. 10 different alphabets are given. This is simple, guys, you can do it on your own. Words with 5 letters are formed from these. Determine the number of words which have at least one letter repeated. By having at least one letter repeated means repetition is possible. That means repetition starts with one letter and can continue with any number of times. Number of all possible 5-letter combinations from these 10 letters is 10 raised to 5. As I said, number of ways of doing a job done is the product of the number of ways of each of its steps. Over here we have 5 letters, right? So the number of ways of finding a 5-letter word is the product of the number of ways each vacancy can be filled. First vacancy has 10 different ways or 10 different options because 10 different alphabets are used. The same particular alphabet can be repeated any number of times. There's no decrease of options, right? So first one has 10, second one also has 10, third one has 10, fourth one has 10, fifth one has 10. That is 10 raised to 5. Now number of all 5-letter words from these 10 letters without repetitions. That is 10 for the first alphabet, 9 for the second alphabet, 8 for the third alphabet, 7 for the fourth alphabet, and 6 for the fifth alphabet. That is 10 into 9 into 8 into 7 into 6. That you get 30240. Number of 5-letter words with repetitions at least once. That is 10 raised to 5 minus 30240. Over here, that is, we subtract the number of combinations where repetition is not possible from the total number of combinations. We subtract the number of combinations where repetition is not possible with the total number from the total number of combinations. Thus, the resulting number of combinations is the number of combinations where repetition does happens at least once and more than once. I hope you understand. So that's it, guys. I hope you liked my video. Please like, share and subscribe. Peace.